This is AP Calculus AB. We're looking at particle motion and the fundamental theorem of calculus. This is the third video, and we are investigating it graphically. The graph of the velocity, measured in feet per second, of the particle moving along the x-axis is pictured. So this is velocities. The position, p of t, of the particle at t equals 8 is 12. That is an ordered pair. P of 8 equals 12. I would write it in that form for sure. Use the graph to answer the following questions. What's the position of the particle at t equals 3? Since it mentions 3, we should probably break this picture apart at 3. Here it mentions 8. We should probably break this graph apart here at 8. Here's what I mean when I say that. We should find this area, this area, this area, and this area. This area here is a trapezoid. It's half the height times the sum of the bases. Height in this case is measured, excuse me. Height is measured this distance here. I got a cold, I'm sorry. It's the distance between the bases. Bases are the parallel sides, so that height is 5. This base here is 2, and this base here is 1, 2, 3. Scratch that. This base here is 1. We're going from 3 to 4. So the height is 5, and the bases are 1 and 3. So this is half of 5 times 4. Half of 4 is 2. 2 times 5 is 10. So this area is 10. This is the same shape with the same dimensions. It's also 10. Here we have a triangle. It's below, so it's going to be negative 1/2 base times height. Negative because it's below the x-axis. So its dimensions are 2 by 2. So it's negative 1/2 times 2 times 2. 2 times 2 is 4. Half of that's 2. So this area is negative 2. So each of these are negative 2. And each of these we said are 10. All right. Those are the graphs. Let's get back to the question. What's the position of the particle at t equals 3? Since we're trying to figure out what it is when t is 3, and since we know what it is when t is 8, we are going to want to integrate from 3 to 8 the velocity function, which we don't know what the function actually is, and that should give us the position at 8 minus the position of 3. This is the fundamental theorem of calculus. So the position at 8 is simple. We're told that's 12. The position at 3 is what we're trying to find. Now we should be able to use our graph to figure out what this area is from 3 to 8. Now if you wanted to get all technical about it, we could say, well, this would be integrating from 3 to 6, and then from 6 to 8. Let's get technical. We're integrating from 3 to 6 the velocity, and then we're going to integrate from 6 to 8. That's because those are the two different shapes that we got. From 3 to 6, the area is 10. From 6 to 8, we're saying it's negative 2. So that's going to be 8 is 12 minus position at 3. So negative 4 is the negative position at 3. So the position at 3 is 4. It would not be crazy to not write this step. In fact, if that makes it more confusing for you, then don't write it, although technically this is the correct work. What's the acceleration when t is 5? Well, to find the acceleration at 5 would be to find the velocity's derivative at 5. Since we don't know the velocity function, we can't take the derivative. Keep in mind, this is velocity, so the acceleration is going to be the slope of the velocity. At 5 is right, pardon me, at 5 is right here. This is a segment. A segment slope never changes. So the slope here, we go down 5 and to the right 2. So the slope is negative 5 over 2. We should probably give units for this. The acceleration is measured in units per time squared. We were told this is in feet per second. So this would be feet per second squared. And if we wanted to get crazy about this here, this previous problem, the position at 3 seconds would be 4 feet. C, what is the net distance the particle travels from 0 to 10? Well, to find net distance, we're going to integrate from 0 to 10 the velocity function. As opposed to total distance, we would take the absolute value. From 0 to 10, I could basically break this down from 0 to 6 and then 6 to 10, because this area is 20 and this area is negative 4. If you didn't want to break it down like that, you wouldn't have to. So I'm going to go 0 to 6, the velocity. It's antiderivative. And then from 6 to 10, the velocity is antiderivative. So this is 20 and negative 4. So I'm going to get 16. The net distance is 16 feet. What's the total distance the particle travels? Well, the total distance is basically what I just did with some absolute value bars. So integrating from 0 to 10, the absolute value of the velocity, which basically means we ignore things that were negative. We don't ignore them entirely, we ignore the negative sign. So from 0 to 6, the absolute value of the velocity, and then from 6 to 10, the absolute value of the velocity function's antiderivative as well. So it's the absolute value of 20 plus the absolute value of negative 4. That's going to give us 20 plus 4, which is 24 feet. The total distance that this particle traveled from 0 to 10 seconds was 24 feet. Its net distance from its starting point from 0 to 10 is 16 feet. That concludes this video. And the next one, we are going to look at the fundamental theorem of calculus, particle motion, using tables.